Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty and today we will discuss about the Bell Coleman Cycle. I will discuss the Bell Coleman Cycle and its application, the Bell Coleman Refrigerator. So Bell Coleman Cycle was actually developed by Bell Coleman and Lightfoot, and they could able to reverse the Joule or Brayton cycle to develop a refrigerator which was using air as a refrigerant. So first I will draw the schematic diagram of the refrigerator and explain the utilities of individual components, and then we'll discuss the Bell Coleman cycle with detailed PV and TS diagram. This component is your refrigerator, and then you do have a compressor. After that, you have a cooler, then you have an expander. So this is refrigerator, this one is your compressor, this one is your cooler, and this one is your. So direction of the refrigerant flow has been shown. This is cooling water, and then here we are having brine solution. So first, how the system actually works. Air is used as a working substance or refrigerant, and air moves through all the components, and air is actually a refrigerant in this particular case. So first, air will enter the refrigerator. In the refrigerator, it will receive heat from the space to be cooled. Then it is taken to the compressor. In the compressor, it will be compressed. Due to compression, its pressure and temperature would be significantly raised. Then it is taken to the cooler. In the cooler, it will deliver heat to the surrounding cooling medium, which is of course your cooling water. And after that, it is taken to the expander. In the expander, it actually undergoes expansion. As a result, its temperature is significantly reduced. Then it is taken to the refrigerator to start a new cycle. As far as the air cycle refrigeration system is concerned, it may be open air or closed air refrigeration system. In open air refrigeration system, air is directly led to the space to be cooled of the refrigerator, but in closed air refrigeration system, we do have a secondary refrigerant which is called your brine solution. Brine solution is a saltwater solution, and when you have brine solution, then air actually interacts with the brine solution. First, heat will be transferred from the space to be cooled to the brine solution, and then that heat is delivered to the air that is entering the refrigerator as refrigerant. There is a reason for which we do go for the closed air refrigeration system, because if you go for closed air refrigeration system, then you can maintain the lowest possible pressure of air higher than the atmospheric pressure. Thereby we can achieve higher coefficient of performance. Once would derive an expression for that, you would understand that that is the reason we go for this closed air refrigeration system. Another advantage of going for closed air refrigeration system, that when it comes to your open air refrigeration system, air may carry moisture, and when it passes through the expander, there is possibility of frost formation which may choke or clog the pipeline. So for that reason, usually we go for closed air refrigeration system. You can eliminate the brine solution and still you can run the system also. Now, we'll represent this in PV and TS diagram. By convention, the entry point to the compressor is taken as point 1. So this is point 2, this is point 3, and this is your point 4. That means entry to the cooler is taken as point 2, entry to the expander is taken as point 3, and entry to the refrigerator is taken as point 4. So we will actually represent the cycle, that is Bell Coleman cycle, in PV and TS diagram. This is the PV, and you have a TS diagram also. 1, 2, 3, 4. So we can see that two of the processes are isentropic processes and two of the processes are constant pressure or isobaric processes. So this is same when you compare the processes with that of your Joule or Brayton cycle, but the processes are actually reversed. And you can say that the Bell Coleman cycle is also a modification of the Reversed Carnot cycle. In Reversed Carnot cycle, you do have two isentropic processes, but you do have two isothermal processes. So the isothermal processes are actually substituted by two isobaric processes. Now, coming to the thermodynamic processes, the processes are 1, 2, 2, 3, 3, 4 and 4, 1. So 1, 2 is actually isentropic compression process. So you can see that in isentropic compression process, the specific volume drops from V1 to V2, the pressure increases from P1 to P2, and the temperature is also increased from T1 to T2. The second one is constant pressure cooling process. The isentropic compression process takes place in the compressor, and the constant pressure cooling process takes place in the cooler. So here the specific volume of air drops from V2 to V3, pressure remains constant, and temperature drops from T2 to T3. 3, 4 represents isentropic expansion process. So in 3, 4, as you can see, the specific volume increases from V3 to V4. The pressure drops from P3 to P4, and the temperature drops from T3 to T4. The last one is your constant pressure heat absorption process. Some people do represent this as constant pressure expansion process. That also you can say. Now, in process 4.1, as you can see, pressure remains constant, specific volume increases from V4 to V1, and the temperature increases from V4 to V1. And 3.4 is what is actually taking place in the expander, and 4.1 is the process which is taking place in the refrigerator. Now, we will find out the coefficient of performance or the C.O.P. of the system. All of us know that the C.O.P. is actually the ratio between the heat absorbed divided by net work done. So, heat absorbed divided by net work done or W net. So, heat absorption is taking place in process 4.1. So, this is Cp multiplied by T1 minus T4. All of us know that for a cyclic process, the net work transfer is equal to net heat transfer. So, this is W net or Q net. So, what is Q net? Q net is actually the difference between the heat that is delivered to the surrounding cooling medium in the cooler minus the heat absorbed in the refrigerator. So, heat that is delivered to the surrounding cooling medium in the cooler, Cp multiplied by temperature difference T2 minus T3 minus the heat absorbed is Cp into T1 minus T4. So, that is equal to T1 minus T4 divided by T2 minus T3 minus T1 minus T4. So, you can denote this as equation 1, which actually represents the coefficient of performance of the Bell Coleman refrigerator in terms of temperature parameters. Now, you can also represent this in terms of pressure ratios. So, now we will derive an expression for the C.O.P. of the Bell Coleman cycle in terms of pressure ratios. So, C.O.P. you can take T4 common, so it becomes T1 by T4 minus 1 divided by, you can take T3 common, so it becomes T2 by T3 minus 1 minus, you can take T4 common, so that it becomes T1 by T4 minus 1. Now, we will prove that T1 by T4 is equal to T2 by T3. So, how to do this? All of us know that 1,2 is an isentropic process. So, for isentropic process 1,2, T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. Similarly, for isentropic process 3,4, T3 by T4 is equal to P3 by P4 to the power gamma minus 1 by gamma. But all of us know that 2,3 is a constant pressure process or isobaric process. Similarly, 4-1 is also a constant pressure process or isobaric process. So P3 can be substituted by P2 and P4 can be substituted by P1. So it becomes P2 by P1 to the power gamma minus 1 by gamma. If this is equation 2 and this is equation 3, let's take this to be equation 2, this to be 3 and this to be 4. Now, if from this what we actually conclude that T2 by T1 is equal to your T3 by T4 is equal to P2 by P1 to the power gamma minus 1 by gamma. Let it be equation 5. Now, from this T1 by T4 is equal to T2 by T3. So you can substitute T2 by T3 by T1 by T4. So now the C.O.P will be equal to T4 divided by T3 minus T4. Because once you substitute T2 by T3 by T1 by T4, these terms will get eliminated and you get C.O.P is equal to T4 divided by T3 by T4. And if you divide both the numerator and denominator by T4, you get C.O.P as 1 divided by T3 by T4 minus 1. That is 1 divided by P2 by P1 to the power gamma minus 1 by gamma minus 1. But what is P2 by P1? You can take this as your pressure ratio. So this becomes 1 upon Rp to the power gamma minus 1 by gamma minus 1. And this expression actually represents the coefficient of performance of the Bell Coleman cycle in terms of pressure ratios. So now you have two expressions for C.O.P. For clarity, let me rewrite those expressions. C.O.P. in terms of temperature parameters may be represented as T1 minus T4 divided by T2 minus T3 minus T1 minus T4, and that is also equal to 1 divided by Rp to the power gamma minus 1 by gamma minus 1. So once you know the temperatures T1, T2, T3, T4, you can find out C.O.P. And once you know the pressure ratio also, you can find out the C.O.P. So one thing that I have told you at the beginning, that by going for the closed air refrigeration system, you can maintain minimum pressure at a higher value. So if you maintain a pressure at a higher value, the C.O.P. will improve. That can be observed because higher will be the minimum pressure, lower will be this value. So you get better C.O.P. So these are the things related to the C.O.P. So we have discussed in detail the function of the individual components, and also we have derived the performance parameter, that is C.O.P. in terms of both temperature parameters as well as pressure ratios. One thing that I would like to tell, that owing to lower C.O.P. and particularly with development of the vapor compression and vapor absorption refrigeration systems, this system has become obsolete. Earlier, it was used to carry frozen meat, particularly in ships. So I sincerely believe that your concept about the Bell Coleman cycle would be crystal clear once you watch this video. If you have any doubt related to this, please do put questions so that I will try to answer. I would request you to subscribe to my channel Erudispace if you have not done so till now. Please do share this video with your friends and relatives to improve its visibility. Hope to see you soon for another lecture on my YouTube channel Erudispace.